I'm Cliff Jones. I am an associate professor from the Department of Ichthyology and Fisheries Science at Rhodes University, which is in South Africa. My main area of research is aquaculture with a focus on integrated aquaculture and developing sustainable technologies.
So what have you been working on during the last months?
As part of AquaVitae, I'm working on a number of the different case studies. Two of them are IMTA studies, integrated multi-trophic aquaculture. The one is a land-based project where we are integrating the culture of abalone, which is farmed in tanks on sea, with the culture of macroalgae and alga, where the alga actually take nutrients and dissolved co-products. We don't call them waste anymore, co-products out of the water, and used as a nutrient source for their production, and the alga actually can then be fed back to the abalone, reducing the environmental impact, less waste going out to sea, and of course reducing the feed costs for the abalone. In addition to that, we're incorporating sea cucumbers into the cycle, where the sea cucumbers utilize, again, feces as a co-product from the abalone as a nutrient source, and the sea cucumbers can then be harvested. They're actually sold as a delicacy in the East. In addition to that, we're doing, I'm involved in a sea-based IMTA or multi-trophic aquaculture project, where we are culturing Gracilaria, which is also a macroalgae, on existing mussel rafts, and then the metabolites from the mussels are used as a nutrient source for the algae, and or moreover, the algae don't compete with the mussels for anything, or we're pretty sure that they don't, and that's what the investigation is looking at. So we better utilizing existing infrastructure where mussel rafts already exist, infrastructure such as boats and cranes and pack houses already exist and potentially not always fully utilized, and the inclusion of an alternative product such as Gracilaria or another macroalgae could contribute to the better utilization of that resource and more efficient aquaculture production. We're also looking at developing biosecurity methods when it comes to integrating different trophic levels into a system. So for example, we might take alga, which is a macroalgae that has been grown in abalone effluent, and it's current practice to feed that back to the abalone, but there are potentially biosecurity issues. You might transfer disease back to the abalone, or if you're transferring one aquaculture species from one system into another system, there's always the potential of transferring disease. So we want to reduce the potential loss due to biosecurity by developing technology to ensure that pathogens in the form of bacteria, fungi and viruses aren't transferred from one organism to another, particularly when feed, and we're using algae as our model product or as our model organism at this stage, is incorporated in feed. We just want to make sure that when we then feed that back to animals, we don't or we reduce the chance of breaching any biosecurity.
How can the society be affected by the results?
So aquaculture in many parts of the world has a fairly negative negative public perception because of the negative impact that it has had on the environment. Integrated multi-trophic aquaculture reduces environmental impact. And in fact, one of the things we're doing in this project is measuring that environmental impact through sustainability studies and through what we refer to as life cycle analyses, where we actually measure the carbon, nitrogen and phosphorus in the system, goes into the system, that gets taken out of the system, and we use that to measure the environmental impact. And so one of the main outcomes of this project will be demonstrating and putting numbers to the impact that and potentially the reduced impact that integrated multi-trophic aquaculture has on the environment. And coupled with that are reductions in production costs, for example, and more efficient utilization of resources. Feed costs get brought down, equipment gets used more efficiently, which will then ultimately reduce the cost of production in aquaculture.
AquaVitae, unlocking the potential of sustainable aquaculture.